Hello students, today we will start our new topic, one of the property of plane mirror, that to see the full image in plane mirror, the least size of the mirror should be half of the height of the observer. Why the least size of the mirror should be half of the height of the observer? We can find out it by a derivation. Now we will start it. Suppose PQ is a plane mirror. In front of which a person XEY is standing. X, where E present the position of his eye. For a person to see his full image, the ray of light from his head X after reflection from one end of P of the mirror should reach the eye E. So now first of all, a ray from the head of this person means X is incident on the mirror, and for person to see his head, this light should be reached in the eye. So suppose after reflection this ray will go like this, where this line represents the position of normal. Now similarly also the ray of light from his foot Y after reflection from the other end Q of the mirror should reach his eye E. The ray XP from the head of man is reflected from one end P of the mirror to his eye along PE. Now also the ray of light from his foot Y after reflection from the other hand Q of the mirror should reach his eye E. The ray YQ from the foot of the person is reflected from the other end Q of the mirror to his eye along QE. This is reflected ray, and here this middle line represents the normal at the point of incidence Q, which is suppose M. The image of X will be X dash on the other side of the mirror, and similarly the image of Y is Y dash. So for person to see his full image X dash Y dash, the least size of the mirror required is PQ. At the point P, the normal of mirror PQ is N. Similarly, at the point Q, the normal on the mirror PQ is QN. Now, as we know, by the laws of reflection, angle I is equals to angle R, means angle of incidence is always equal to angle of reflection. That is, we can write from here that angle XPN, it will be equal to the angle NPE. Since these two angles are same, XPN and NPE, so we can say the distance XN will be equal to the NE. Similarly, from the lower triangle, we can say by the laws of reflection, the angle YQM will be equal to the angle MQE. If these two angles are equal, then we can say distance EM is equal to YM. So now the size of mirror PQ will be equals to NM, we can say. NM, it will be XY, total length, total height of the man, minus XN plus MY. This will be equal to NM, and NM is the PQ, the size of mirror. Now, XY minus bracket, since we know XN is equals to NE from the first equation, plus MY is equals to ME from the second equation. We can put here XY minus NE plus ME, NE plus ME. It is equals to NM, or you can say PQ. Since NM is equals to PQ, so what you get? PQ equals to XY minus PQ. So, we can write PQ plus PQ equals to XY, means PQ equals to XY by 2. Means, what is the PQ? PQ is here the size of mirror, and what is XY? XY is the height of person. So we can say, to see the full image, the least size of mirror should be half of the height of the observer. Now, next topic, relation between velocity of object and image. From the mirror property, as we know, distance of any object from the mirror is always equal to the distance of image from the mirror. Okay, so we can write in symbolic form as, suppose x denotes the distance, so we can write here x IM is equals to minus XOM, where XIM represent the position of image with respect to mirror, and similarly XOM represent the position of object with respect to mirror. Here I symbol is used for image with respect to M means mirror, and O denotes the object with respect to mirror. So position of image with respect to mirror is always equal to the position of object with respect to mirror. And why here negative sign? Negative sign because if the object is placed in the one side of the mirror, then its image will be formed at the another side of the mirror. Similarly, we can say In terms of velocity, we can say VIM will be equal to minus VOM. Means velocity of image with respect to mirror is always equal to the minus of velocity of object with respect to mirror. VIM represents here velocity of image with respect to mirror, and VOM represent velocity of object with respect to mirror. So this was the relation between velocity of object and image. Now we can apply this relation in numericals. Suppose first numerical is an object moves with 5 meter per second towards right, while the mirror moves with 1 meter per second towards left. Then find the velocity of image. So first we will draw a figure. What is given in question? The question is, suppose a mirror is this, an object is placed at a certain distance from the mirror. Now given in question that object moves with 5 meter per second towards right. So it is moving like this, 5 meter per second. And again what is given? The mirror moves with 1 meter per second towards left. So it will be like this, 1 meter per second. Now as we know the relation of velocities between image and object, Vi minus Vm is equals to Vm minus Vo. Here what is given? V mirror. Suppose we take this direction as positive, right direction. So left direction will be as negative. Since mirror is moving towards left, so its velocity will be minus 1. And velocity of object, since it is moving in right direction and we have considered right direction as positive direction, so its velocity will be plus 5. Now by putting the values in this equation, we get Vi. We don't know Vi, what is the velocity of image, we have to find minus Vm. Vm is minus 1 equals to Vm again minus 1 minus Vo, it is 5. So we get Vi plus 1 equals to minus 6. So Vi will be minus 6 minus 1. So it is minus 7 meter per second. Means minus 7 means the velocity of image will be 7, and what minus sign represents here that image will be move in direction of minus, means left. So 7 meter per second is the velocity of image and direction towards left. Since velocity is a vector quantity, so while calculating vector quantities, we have to assume a direction. We have to consider the signs for specific directions. For one direction, we can assume as positive sign, and for the opposite direction, we can assume as negative. Now, next question, next numerical. there is a point, object and a plane mirror. If the mirror is moved by 10 centimeter away from the object, find the distance which the image will move. Since in this question we have to find the distance, so we have applied here the formula in terms of position means distance, and that was the x im is equals to minus x om, or we can write it as x I minus xm equals to minus of xo minus xm. Now here x denotes the displacement of image, mirror, object respectively. Suppose it is this, and this plane mirror and object, certain object O is placed at a distance, suppose x from the mirror, then image will be from the property we know image will be formed at the same distance x dash. Now given in question, if mirror is moved by 10 centimeter, suppose now the mirror moved by 10 centimeter, it was at its initial position, now it is moved 10 centimeter. So now the new position of mirror is this. So since object is not moving, so now the distance between object and mirror will be, it will be x plus 10. So by the property, the image will also be formed at the x plus 10 distance from the mirror, and we don't know this distance. The initial position of the distance between initial position of image and the new position of image, suppose it is t. So it is clear the question. What we have done, actually we have assumed initially the mirror is this and the object is placed at a x distance from the mirror. So by the property of plane mirror, the image will be formed at the same distance, it is x dash. So when mirror is shifted by 10 centimeter from the object, so and object is at rest, so the new distance between object and mirror will be x plus 10, and from the property the image will be also from the mirror at x plus 10. Now we have to find the distance which the image will move, means the initial position of image, the distance between initial position of image and the new position of image, means this d, and let the distance is d. Now this x represent the position, so we can also change the we can write this formula in the terms of change in position, delta xi minus delta xm equals to minus of delta x0 means x object minus delta xm, where delta xi represent the change in position of image, change in position of mirror, change in position of object, and change in position of mirror. Now change in position of object, it is 0 because object is not moving, so change in position of object is 0. Now change in position of mirror, it will be initial position was this and the new position is this, so change in position is 10 centimeter. Therefore by putting these values in equation, first we can get delta xi we have to find, and we have assumed this as d. Delta xi means change in position of image. So change in position of image we have assumed this d minus delta xm. It is 10 equals to minus of delta x0, it is 0, minus delta xm, it is 10. So d minus 10 equals to minus plus 10. So d will be 10 plus 10, it will be 20. So we can conclude this that the change in position of image will be 20 centimeter. That means image will move from its initial position from the 20 centimeter. So we get 10, d is 20 centimeter.